Hey there, adventure buddies. I want you to say hello to my little friend. This is a 12 millimeter diameter, 16 millimeter bore wobbler engine. Check that out. Isn't that some neat function? So, why did I get here? How did I end up here? Well, first off, let's see it run. If I add just a little bit of air here, say 10 pounds, she cruises right along nicely. Look at that. Isn't that sweet? So what's up? Why is that bolt shaking back and forth? Not really spinning, it's just kind of shaking. I can put my finger on it. The piston's going around, the cylinder's knocking around like crazy. What's up with this, huh? Let's speed it up a little. Ooh, yeah. That's moving now, ain't she? Brrr! Full steam, Captain. Oh, yeah. She's really running balls out now. I know that's not a derogatory term. Back in the days of steam, when you'd see those little weird generators. Let's turn this down. Ooh, 15 pounds. She really started getting rowdy. I'm around 10 now. But balls out is, you know, those little governors you'd see on the steam engines with the dingleberry balls in the end that would swing out. Well, the further they'd swing out from centrifugal force, and what that would do is operate a shaft down the center and control govern back the timing of the motor. But this one's not governed. But at 15 pounds, you know, it makes decent power for being a small, 95% 3D printed motor. Clearances aren't that great on it, and there's no combustion going on here. It's just straight air. It's not even steam, so you don't get the flash of hot steam. So you're all wondering how this works, and I'm yammering on about it, playing with it. You just stop it. Sometimes it'll self-start depending on where. Put it right. Just because I know the timing and how the motor's set up. But yeah, let's take it apart and show you how it works, shall we? So, this is our air inlet. It's offset, that's for a reason. This is just a counterweight random chunk of metal I found around. Inside there's a skateboard bearing. That is our one single ball bearing that's acting as our crank bearing. Our crank, just a round circle because it's easier to design like that. I might end up like fish mouthing it out and make it look like a proper counterweight, but 3D printed, that doesn't matter. Now the meat and potatoes. So if I unscrew this nut and just curiously holding a spring down, you'll see it just all kind of comes apart. And what the heck just happened there? So let's start here. This is what I like to call the pedestal. So that shaft went through here, bangity, and that right there is straight through to our air hole. You could see right through the backside there. Now, why is that all magical, and why is that the way this works? Well, if you look at the piston, or the cylinder assembly, it's straight, flat back here. The shaft is locked solid to it, and there's a hole, but the hole's dead center. Well, the way this thing works is the other magical bit is there's no wrist pin in the piston. So as the crank, let's say it starts here at the bottom. Let me put it on the bottom of the crank arm. So if we're down here at the bottom, the cylinder, centrifugal force pushes it up, which is holding the cylinder over its side. And then it's turning it, and this is where a lot of the bind and the loss and the friction is because the crank is actually turning the piston the crank is turning the piston that is inside the cylinder and rocking that all the way over. When that rocks it over, remember that hole that's lined up right here that's straight through to our cylinder? It rocks over, and instead of being somewhere over in this neighborhood, it rocks over and bam, it lines up with this port. When it does, This motor, when operating from the front, going like this, clockwise, when it rocks over, bam, it introduces a shot of air, drives the piston down. When it drives it down, the piston hits the bottom. Again, that rocking motion takes into effect. The piston's in the cylinder. It rocks the cylinder straight upright. As it does, it closes that port. Centrifugal force carries it around. Pretty neat, isn't it? Now, this is a really popular style motor for really small steam launches and small steam toy engines. The reason is this style of valve, which is called an oscillating cylinder or a wobbler, is a very popular design, mainly because it's simple and it's effective. Now, with 3D printing, you have this rough, because it's an additive process, layer by layer by layer by layer built up, and you can actually see this pedestal is printed like this. You don't end up with this nice face, so I've actually had to smooth using sandpaper and a flat surface. Before I put the stud in, I polished the cylinder face down here and the pedestal face down here where they interact, and you can see I'm done. Probably could have took a little more time there. That's kind of critical, and I'm not helping it by rubbing it, but that's where the key is. Now, I found these files. The guy's slipping his name, but I'm definitely going to link him down below. These were originally a machinist project files, and I just copied his design work, and I just built this off this versus doing all the engineering myself, just because it's simple engineering, and I didn't want to do all the math. So I'll link his files below, and that way you can machine it if you want to yourself, or just read the original source files, and I want to give credit to him. And then also, if you have a 3D printer, you could go ahead and print one of these up. You're going to need some random screw and some other random screw and some 3/16 brass line and a spring and a nut, and yeah, a couple hours of print time. This is all PETG just because I like PETG. Anyways, I hope this kind of explains the motor to you guys, how it works and what it does. And stay tuned, because this has definitely become a little obsession for me, building these little kind of motors up. They run particularly good. I have some ideas in mind, but I want to kind of work out some of the flaws, maybe make some more power, try to seal the cylinder a little bit better to the piston, and yeah, we'll just go from there. But in the meantime, I'm going to put this back together, and just because it's easy to do. And this spring is what actually holds the cylinder face in line with the pedestal and holds all the tension on the whole operation. But I want to plug this back in here, crank her up, and just leave you guys watching it run.